If you haven't seen the previous video on the sine function, where we have a very similar looking thing as this, but we're instead of looking at cosine, we're looking at sine, I encourage you to go look at that. I explain a little bit more about the relationship between these two things. But here on this graph on Desmos, we have on the left the unit circle, and then on the right is just the x and y coordinate plane. Basically, is a y-axis here where the maximum value is 1 and the minimum value is -1, and starting at 0 going all the way to 2 pi. So the horizontal axis here is actually in terms of angles. It's like as we change the angle. So I'm going to change the angle here, and what we're going to be graphing is cosine. And cosine is a relationship when it comes to the unit circle between the x value of this coordinate point that will go along the circle as it relates to the angle. So as we change the angle, what's happening to this x value? So recall, like one thing, right? That cosine is the adjacent over the hypotenuse, and if the hypotenuse, so here the unit circle is 1, then the adjacent side of this triangle, or this horizontal, the x value of this point, right? The horizontal part, that is cosine, right? So it's just a horizontal part divided by 1. So as we change, like when we started at 0 degrees, cosine was 1. And then as we rotate up into 90 degrees, cosine is going to get closer and closer to 0. It is 0 at 90 degrees. And then it's going to get like less than 1, right? Because this is now the negative side over here. So these are negative values. And then it's going to go all the way to -1 when it's at 180 degrees, or pi. Then it'll be back to 0 at 270 and back to 1 when it gets back to 360 degrees, back to 0 again. And it keeps going on and on forever because just like sine, cosine is a circular function, or it's a periodic function, just like all trigonometric functions are. So actually cosine is more versatile when it comes to something called regression. Regression is the way that we fit data to points. And the reason that cosine tends to be a little bit more useful for that is because if you were given a bunch of data, in fact, let me pull up a uh, another graph here. I should have had this ready to go. Um, so here's just a bunch of data that's plotted, and if I turn these graphs off, this is sinusoidal. So sinusoidal is the general shape that a cosine or sine curve make, and it's much easier. It's easier to pick out the maximum or the minimum values from a curve like this. It's much harder to know where the middle is. You can do some fairly simple math, like find the average height to find where the middle would be. But if you're just looking at the data itself, it's easier to pick out a maximum or a minimum point. And so if we go back and look at cosine, cosine starts, like positive cosine starts at a maximum. So it's easier for us to say, all right, that maximum, we're just going to translate it up or down, up, down, left, right to where it needs to be. And then that's already going to really match up pretty well with our data. Now, we don't talk about cosine regression, we talk about sine regression. And that's because sine and cosine are so closely related. Sine is considered like the main function, and cosine is considered the cofunction. That's why it's just called cosine. Now, there are two other cofunctions in trigonometry. We're going to talk about tangent after cosine, and the cofunction of tangent is cotangent. We're going to then talk about secant, and the cofunction of secant is called cosecant. And here's an interesting thing about the relationship between a function and its cofunction. So, with some exceptions due to domain restrictions, if you have let's just talk about sine and cosine here for an example. As an example, the sine of an angle is equal to the cosine of the complementary angle. So if you have a function like for example sine, right, and a is so sine of 10 degrees, that means if we subtracted 10 degrees from 90 and got 80, so b in this case here is 80 degrees, that means that the sine of 10 and the cosine of 80 are the same. And that will work for any value here. Look, as we change this, as we have values as we take, like you just do this math. Like essentially all we're doing here is having A is an angle, and then B is the complementary angle to that. We know that complementary angles add up to be 90 degrees. So if we take the sine of an angle, like, and this makes sense too, right? 210 degrees on the unit circle. So if we go back to the unit circle, right, 210 degrees is right here, and the cosine of 210 degrees, sorry, the sine of 210 degrees is negative 0.5. If we wanted what's the complementary angle to this, we'd be then looking at, so if we 210, 90 minus 210 is negative something else, negative 130, negative 120, which is going to be the same thing as 240. That is the same thing as my negative cosine value here, right? The sine was negative 1.5. The cosine is negative 1. Sorry, the sine was negative 0.5. Cosine was negative 0.5 of the complementary angle. And so we can actually see, right, if I wanted to know like the tangent, so that's tangent, and then cotangent, I think I can do cotangent here, yeah. And so you can change these values, see that they're the same as you go through. The other one is secant and cosecant, which we call C as C. And then we have, yeah, this is the same thing. So this is a very powerful property, because if we're looking at different functions, and we have a value for one of them, but it would make the math really complicated, we can just sub in another one. We could say, oh, because the sine of 10 degrees is equal to the cosine of 80 degrees, maybe it's much easier for me to use cosine of 80 degrees than the sine of 10 degrees, depending on the problem. Later on, when you get into in your full-fledged trigonometry class, whether you learn that through here watching my videos or you watch it somewhere else, you will get into something called trigonometric identities. And those are like this idea here is very important for those, because you can take a very complicated looking statement and substitute some equivalent value in and make it much less complicated, which is ultimately that's a good thing. If we know values that are the same, we can substitute. Now notice how I set this for secant and cosecant. These are functions we haven't talked about yet, but they have domain restrictions. So cosecant has a domain restriction at negative 180 degrees, and we'll talk all about that later, but the reason for that is that the sine of 180 degrees is 0. And then you'd have 1 divided by 0, and that's undefined. So anyway, that is cosine. It's a cofunction of sine, and it's graphing. The graph looks very similar. In fact, really, if you think about it, if we go back to sine and cosine here, what is happening with cosine, right? We are subtracting some value from our input, or I guess we're adding it, right? So this would be, if I went inside here, that I'm taking this inside part, which is the input, and I'm adding or subtracting a value from it, which implies there is a horizontal translation. So really, the graph of cosine is just a shift of pi over 2 to the left of sine. And so we can, or pi over 2 or 90 degrees from sine. And so we can apply that thinking. The graphing of sine and cosine are very, very similar. They're basically the same thing. And that's the next video. We'll talk about graphing different versions of the cosine function.